Okay, the switch finally come in from Walmart. That's for my door alarm. I got the door alarm sockets inside this with a buzzer on top. It's Velcro together. It's Velcro together to the telephone box thing for the cord I have inside this. And the cord inside takes this 4-pin telephone cord. Since I wanted something that was flat, that wouldn't break if you close the door on it, and also something that would reach from the door to the outlet. Anyway, we got there, and I put the box facing the connector on this side is up there, so that means that if the only way to unhook to unhook it, you have to open the door and the alarm will go off. Anyway, over here is the sensor. This is the reed switch, the magnetic reed switch for it that takes a magnet right by it and it will turn it off and it'll turn on. It's using a single pole double throw one, which means it switches between two different things. It takes a capacitor and switches it between the positive voltage and then the buzzer. Right now it's on the positive voltage, and if I open the door, it's going to the buzzer, as you'll see. See? And you can hear it going down low as time goes on. That's how capacitors work. And if you close the door, I'll show you behind the door. We have down here, there's a box right there, another telephone box thingy, and the 25-foot cord that I got at a good price at All Electronics, was 65 cents. And it was flat enough for the application I was going to use it for. It has 4 wires. I only needed like 2. So what I do with the other 2, I split them in half and put equally the same number of wires for each one. 2 for positive, 2 for negative. So in case one wire goes bad, let's say the door did something to the wire. If the door breaks one wire, it's still going to work. Just in case. As you see here, there's the power cord right there that goes to power supply. I could have used batteries, but then again, you have to buy a battery holder, then you have to buy batteries. If I skip that part, since I already have a power supply, I can save money. And another thing is, batteries that could go dead. Well, they'll last a long time off this circuit here, as long as the door is not open constantly. No, wait a minute. Yeah, it'll last a long time. Because as capacitors get charged up, the current goes down. Then it'll draw less from the battery as it will get more charged. Barely to anything. Why I put capacitors in it is so that it's not a constant on when it opens. That would be annoying if you open the door and it made that buzzy noise constantly until someone closes the door. So what I did is I made it where it charges up a capacitor when the door is closed, and then discharges it to the buzzer when it's open. This cord is like pretty long. We measured it from here, and it went all the way to the bathroom over on the other side of the house. Not on the other side of the house, the side on the hallway of mine. That's how long this cord is. And 65 cents is a good deal for it. Of course, there's like $8-9 in shipping, but if you get the other parts, it's a good deal. I used to have this cord for transferring, when I was at the other house. I used to use it for hooking up to the TV, so I could watch TV in my room through the monitor, the RCA connection, with one of those box adapters that take like S-video or composite and then convert it to VGA. Anyway, and if you close the door, you'll probably hear a chirp because it makes connection between both of them. If you close it fast enough, see, there it went. You hear that chirp now. And sometimes it may, I don't know if it's going to do it to me where it's going to stay on. I guess it's doing pretty well. Only one time it did turn on and I don't know if it stayed on or not. When we closed it, opened it up again, and it discharged. And it works pretty well. I wish you could get these wires hidden, but that's okay. You'd have to cut them, I think. Anyway, this is a pretty good, neat thing. I think this will actually work. So I hope you enjoyed it. Oh wait, maybe I should show you the schematic and explain it to you. Okay, right here, have it upside down. Okay, right here is a circuit. We're using this one right here, this one. There's 3 different ways you could do this. Well, actually 2. This way is just in case if your buzzer draws too much current and the capacitor just drops rapidly so low that it doesn't make a good time staying on. You can use a transistor to switch it on, since transistors don't need that much current, and they'll last longer on the buzzer. In fact, they'll make the buzzer even louder, stay loud, instead of going down low. It'll turn off, but it'll stay on loud if you do it that way. Well, let's just stick with this way, with the one I got from All Electronics. So we did this. We got 9 volts. Oh, actually, it's not a battery. You can use this one. You can use a battery. This one you can't because it's a relay on it. This one here uses a switch that you can find all the tracks that I should have probably did before I thought about this. This switch here, because the switch is hard to figure out how to get past that, because every time the door is closed, the other switches are all electronics happen. That switch up there would have been shut, and then make a connection between it, and it would have drew electricity, and it would now that it would stay on. You have to figure out a way to switch the thing on, when it's not making a connection. You could do it with a transistor. You could do it with that, but it's probably best to use a relay. There may be other ways of doing it, but we're going to go with the ways I have. That way there, in case if you do want to do it my way with the power supply, this way would probably be the cheapest then. See, this is how it works. There's a buzz capacitor there. Now the capacitor value is not important. Well, it is, kinda. You get too low capacitance, the thing's not gonna stay on for 1 second. You get too high capacitance, it'll stay on for hours or minutes. Too long of a time. Usually a capacitor between 470 microfarad to maybe 4,700, maybe even higher than that. As long as you're not talking about going to 1 farad. Then they'll stay on. Oh, it's too long. It'll be like a battery. Anyway, this buzzer here activates when you open up the door. This lead here gets this contact, moves down here, hits that. Discharge the capacitor, goes to there, goes to the buzzer. The buzzer goes off. And the buzzer would slowly discharge the capacitor, so it turns off completely at a certain amount of time. And that's how basically the circuit works. Down here, the same thing, except of using that discharge to the buzzer, it discharges to a resistor, then going to the base of this NPN transistor. With the buzzer's negative connected to the collector of that transistor, and then the buzzer's positive going directly to the positive voltage on the power rail of your power supply. You probably can use battery for that too. This one and this one can use batteries, not the one with the relay, because once it's closed, that switcher is going to be closed, and then it's going to draw current through the coil. This coil has some resistance. It's not that big, and it will not last a week or so if you do it that way on a battery.
Oh, we got money.
Anyway, so if you want to do it for batteries, you probably best doing it by that using the single pole double throw switch. I'm thinking about making another one of these and selling them. I have no idea how much I'm going to sell it for. There's a store on my website you go to. Soon I might have it up there once maybe that might be for next month. Might make another one. Maybe make a plastic black box. Maybe make it take like 4 AA batteries, which will give you 6 volts. 1.5 times 4 equals 6, so that'd be 6 volts. And that there will help. That there will make it where you can have a door alarm for yourself, and it will work just the same way as this one does. Well, that's it for now. I hope you enjoyed the video. Thanks for watching if you like it.